Alright, hey guys. Trying something new today. I'm gonna turn on the webcam. Um, let's move me a little bit. Yeah, I'm gonna try out the webcam this time for more face engagement too. I don't know. It's I'm gonna try this out. I don't know. It might make my videos like more heavier, but I want to try it out. You guys also see that what kind of keyboard I use? Korn. It's a kit. I have built one, but it was not wireless. So, and I tried doing the diodes myself one time. Oh my lord! If you guys built a split keyboard before, you definitely understand the pain. But let's get to it, man. It's day 24 today. Yesterday I took so long because I'm so trash at coding. Um. So yeah, today I hopefully I can redeem myself by getting to it by doing it a little faster. But it's okay. We all learn at the same pace, different paces. I mean, but let's do some mutexes. I know mutexes in C, like locking and unlocking, specifically C++. But it's something to do with like um, what is it? Threading stuff, right? Generics. How long are generics? Okay, we're almost done, man. I'm really excited. Definitely love this Go course. One of my favorite courses is definitely because in the beginning of my programming, when I kind of started out programming, I would say that's my like high school senior year. Um, I'd use Code Academy, but I think it holds your hands a little bit too much. I think this gives you enough information, but I do think I have to like think it out yourself, which is something I appreciate from these boot.dev, but is I still need to do a project, and I plan to do that very soon. Hopefully, maybe this weekend. I don't know. I just never get the time because life gets in the way. But let's get to it. Mutexes and Go. Mutexes and Go allow us to lock access to data. This ensures that we can control which Go routines can access certain data at which time. Go standard libraries provide a built-in implementation of a mutex with the sync.mutex type, and it's two methods, lock and unlock. We can protect a block of code by surrounding it with a call to lock and unlock as shown on the protected method below. It's good practice to structure the protected code within a function so that defer can be used to ensure that we never forget to unlock the mutex. Cause bugs if used carelessly. Maps are not thread safe. Maps are not safe for concurrent use. If you have multiple Go routine accessing the same map, at least one of them is writing to the map, you must lock your maps with a mutex. We send emails across different Go routines at Mailio to keep track of how many we've sent to a given email address using in-map memory. In-memory map. Our safe counter struct is unsafe. Update inc and val methods so that they utilize the safe counter mutex to ensure that the method is accessed by multiple Go routines at the same time. Okay. So let's lock. I gotta lock it. So who's sd.lock, right? It's a lock. sc.mu.lock. I think, right? Then do the same thing but unlock it when you we could do defer. Right after this is done, then not lock again. Unlock. Same thing here. Nice. Interesting. Very good insight. Why is it called a mutex? Mutex is short for mutual exclusion and the conventional name for the data structure that provides its mutex, often abbreviated to mu. It's called mutual exclusion because a mutex excludes different threads from accessing the same data at the same time. What does the term mutex refer to? Mutual exclusion. The principal problem that mutex helps us avoid is the concurrent read-write problem. This problem arises when one thread is writing to a variable, another thread is reading from that same variable at the same time. When this happens, a Go program will panic because the reader could be reading bad data while it's being mutated in place. So you say go here, go there, and then we make a struct, a channel struct, and send data. We're just using it essentially. Oh, this is an implicit for true. Okay, that's really cool. Never knew that. The example above creates a map, then starts two Go routines, and then they both are basically doing it at the same time. Actually, this one map, This does not make a copy of the map. Since it's... Maybe I'm mistaken. Can go. It isn't safe to read from and write to a map at the same time. Mutex is so unlock, lock, do the thing, and then lock it, do it, and then unlock it. So when this is happening, it won't be able to access it, so wait until it gets unlocked, then it does it, then yeah. That's cool. So let's see, how many threads can it lock? There's a pointer. It's called when we're done. This lock / unlock. Wait, how many threads can it like stop? I think like one or something, I'm not sure. Alright, we back. Yep. Yeah, safely do all of that stuff. Alright, let's see. Let's test our knowledge here. Whoops. Come on. So if I go here, okay, so what am I doing? R-lock. What does this do? Multiple goal routines can safely reformat continuously as long as many R-locks calls can occur at the same time. However, only one goal routine can hold a lock during this call. Alright, so okay, so it's stuck forever. Update the update the val. To read lock. And I gotta do a R lock. Very nice. Read, write, mutex, review. Maps are safe for concurrent read access. Not concurrent read /write or write access. A read write mutex allows all the readers to access the map at the same time, but writer will still lock out all other readers and writers. All these are gonna read and write to the same map, but protects it. Because reading isn't terrible as long as you're not writing at the same time. You have multiple people read the same thing, you know, if it's not changing, I assume. Many people? Yeah. How many readers can access a mutex at once? Wait, what? Isn't that the same question? Oh, writers, we could only have one, I think. Readers, we can have many. Can readers and writers? No. I think one will block it out, right? No, I'm not sure. Damn, that was a short course. Or a short section. Should I just continue? Maybe I can try to finish everything. Depends on how long this one is. Let's keep it going. Generics. For a long time, that meant that Go code couldn't easily be reused in many cases. For example, imagine some code that splits a slice into two equal parts. The code that splits slice doesn't care about the types of values stored in the slice. For generics, we need to write the same code for each type, which is a very undry thing to do. Okay. But put simply, generics allow us to use variables to refer to specific types. This is an amazing feature because it allows us to write abstract functions that drastically reduce code duplication. In the example above, T is the type of the name of the type parameter for the split any slice function. And we said that it must match any constraints, which means it can be anything. This makes sense because the body of the function doesn't care about the types of the things stored in the slice. T of any type of, this just has to be an array of things. Wait, return, if it's 0, then return 0 type. Else return s of length of s. Oh yeah, I figured out this new Tmux thing that I really like is the Vin mode, which is super convenient because I don't know, it's just like I don't have to, like, it's like, look how easy it is to copy the stuff, you know? Like, did I pass? Okay, I guess I passed. Generics reduce repetitive code. You should care about generics because they mean you don't have to write as much code. It can be frustrating to write the same logic over and over just because you have some underlying data that are slightly more different. Used more often in libraries and packages. Generics give developers an elegant way to write amazing utility packages while you see and use generics in application code. I think it would be much more common to see generics used in libraries and packages. Libraries and packages contain importable code and tends to be used in many applications, so it makes to write them in a more abstract way. Generics are often the way to do that. Why did it take so long to get generics? Go places an emphasis on simplicity. In other words, Go has purposely left out features to provide its best feature being simple and easy to work with. According to historical data from Go service, Go's lack of generics have been listed as one of the top 3 biggest issues with the language. At a certain point, the drawbacks associated with the lack of a feature like generics just adding complexity to the code. Which code would generics be likely to help with? Detecting whether or not a string contains a given substring, calculating the area of the server, a binary tree. I have no idea. Wait, something does generate. Detect whether or not a string contains a given substring. No. Maybe binary tree, because like the data type could be whatever they want, but I don't know. Calculating the area of the circle. Yeah, I don't know. Calculating the area of the circle. I don't know. It's specific. I use some kind of floating point or integers, right? Go's approach to language design is to support as many useful features as possible, to never add new features. Probably the last one. Probably library packages. Let's see this. Charge line. Sometimes constraints. You need logic in your generic function to know something about the types. About the types it operates on. The example we used in the first section didn't know anything about the types of the site, so we used the built-in any. Constraints are just interfaces that allow us to write generics that only operate within the constraints of a given interface type. In the example above, the any constraint is the same as the empty interface because it means the type in question can be anything. Creating a custom constraint. Take a look at the example of concat. It takes a slice of values and concatenates the values into a string. This should work with any type that can represent itself as a string, even if it's not a string under the hood. For example, a user struct can have a dot string that returns a string with the user's name and age. We have different types of line items that we charge our customers credit cards for. Line items can be things like subscriptions or one-time payments, for example, for email usage. Complete the charge for a line item function. First, it should check if the user has a balance with enough funds to be able to pay for the cost of the new item. If they don't, then return an infant. Oh. Just check if the user has a balance. Okay. If the user has balance with enough funds to pay for the cost of the new item. New item dot get cost. So if balance dot cost they return an insufficient funds error and zero values for the other return values. If they do have enough funds, add the line to the user's history by appending a new item to. Errors. In okay, if it's small, then if they do have enough funds, add the line item to the okay, so old items new, so old items new items, and then new balance is balance minus new item dot get cost. Return the old items, new balance, and no error. Oh, get last. Wait, did I not add the... I don't think I added this line. Awesome. When intergenerics were released, a new way of writing interfaces was also released at the same time. We now simply add a bunch of types to get new interface constraints. What the hell? Oh. Interesting. Why might you create an interface using a type list? For the first one. Very nice. What the hell? Biller. Alright. Parametric constraints. Your definitions can later be used as constraints. Can accept type parameters as well. Okay. It's a product interface of that. So we're implementing the price. So this belongs to a book because we're making a struct that's going to be applying to the book as a product because it's going to be implementing price and name. And the toy is also a product because we also implement price and name. So pointer receiver, we are a this, and what it has to be a product. I see. Or it has to be a collection of products, I assume. The chief architect at Melio has decided she wants to implement billing with generics. Specifically, she wants us to create a new biller interface. A biller is an interface that can be used to charge a customer, and it can also report its name. Yeah, I added this, right? Okay, so we have a interface that takes in only customer structs, right? Essentially, like product interfaces, like structs that implement the product. Okay, I guess I understand. Billing. Specifically, she wants us to create a new biller interface. A biller interface is an interface that can be used to charge a customer. That can be used to charge a customer. And a customer is anyone that fulfills the plan. Who's a customer? This. Anyone who implements the get billing, which is this here. So the struct a new biller interface. A biller interface is that can be used to charge a customer, and it also can report its name. There are two kinds of billers: a user biller and an org biller. A customer is either a user or an org. A user will be billed with the user biller and an org with an org biller. You should have two methods: charge and name. Charge. So charge name. Does it return anything? So it returns bill. And then what about name? A string. Oh, I have to use it here. So with the C. Huh. um. A customer is a user, right? Let's see the user struct. And then the user here is implementing, yeah, it's get. Oh, what? Oh, yeah, it is. User is a customer because it's implement that. Okay. So, what am I doing wrong? Wait a minute. I think charge takes in that. What about name? Name doesn't take anything. Okay, so then I just need to do nothing. We passed. Alright, naming generics. Let's look at this again. Is a variable name. We could have the name type parent anything. T happens to be a fairly common convention for a type variable, similar to how I is a convention for index variables and loops. This is just its value. Yep. Enums. Honestly, I think I can finish the course today. My least favorite, glad you asked. It's the lack of enums, sum types, and tag unions. Statically typed languages. TypeScript. Okay, that's a funny. You know, my issue with TypeScript, I'm so used to JavaScript and TypeScript. I don't know if maybe it's my setup with TypeScript but it's just so lenient sometimes. Like sometimes I'm forgetting I'm writing TypeScript and then like it just doesn't matter because it's valid JavaScript, right? I don't know. It's weird. Maybe I set it up usually wrong, but like for example, if I were to do that in Go, that would break my whole program. You know. Go's type system isn't as powerful. It's more similar to C's type system than it is to Rust. It's more concerned with simplicity than it is with expressiveness. In Rust, like Go, errors are just values. In Go, it'll be something like this. Damn. In Rust, the get user function returns a result type, a type that is either an OK or an error. The compiler forces the developer to handle the error case before they can continue with the happy path. In Go, the developer can choose to happily ignore the error value if they choose to use the user data, even if it's invalid. The support for enums. Can choose to happily ignore the error value if they choose and use it, even if it's invalid. A lazy now I need to make another file. I guess I will. Handle email bounce. Just because the compiler doesn't force us to check errors doesn't mean we shouldn't. Take a look at the update status and track methods in the user.go file. Take a look at the user status. Okay, so let's GD into there. Okay, so if it does return something. It returns that. Okay. See, this is it returns if so let's say we don't need this, but we do need if error. Wait, why am I not allowed to do this? If error does not equal nil, return something. We'll return something, but I don't know yet. Wait, this status thing? What is it? Oh, it just returns an error. So I could just do this. If error does not equal nil, then fmt error. I think hold on, I can redo this right here, right? So fmt error okay. Oops. So wait, what is this one? Can I do this? Oh, should I just return this? Return. Oh, that's the word. Okay. I need to learn these percent stuff. The formatting stuff better. I don't really like Go's formatting, but what can I say? Wait, so what happens when I do this? It fails. If the status update fails, oh, error updating user status. Okay. Error updating user status. Oh, track also fails? Brother, what are you doing? Return fmt error format. Error tracking user bounce. Awesome. For all its fault, TypeScript does a pretty good does have a pretty incredible type system. Here's one thing you can do better that I often miss in Go. The sending channel that we've created is a union type. It can only be one of the 3 strings that we've defined. That means when a developer calls send notification, they can't accidentally pass an invalid sending channel like Slack or even misspelled email. The TypeScript command will catch that mistake at compile time. In Go, we don't have these nice things. We embrace the Grug mentality. The closest thing we have is the union is the here. Interesting, and will not stop us from doing this. So just an alias for string, and because we made it some constant of that time, most of it will just use those constants. Easy to do the right thing. That's it. It doesn't force us to do the right thing like TypeScript does. Okay, I guess that's interesting. That's weird. That's really weird. Use the following code to answer the questions. With a compilation error. Okay, so we're saying if you use the direct string, then it's fine. That's really weird. There's a type. The sending term is just an alias for string. That's really weird. It's just an alias for the data type that it's using here, perm. Check perm. So if I use write, that's fine. User is fine. Perm user, yeah, that would also be fine. Read, that doesn't exist. Oh, that's fine. And admin. Wait, what would it stop us from doing? So you can't just use a random string. So actually would fail at admin, I guess. Okay. But it will be fine with this or another one. Like just placing the right string there. I don't think so. I think that's fine. Because you're like, wait. Yeah, because it's like casting it into this group or something. Which is really weird. Jota? What the hell is this? Iota? That when used with a type alias, but it's it's an iota. Okay. Oh wait, this is, oops. Wait, this is, hold on, copy this. Wait, what am I doing? No, Mango. Should just have package. Oops. Package main. The iota keyword is a special keyword in Go that creates a sequence of numbers. It starts at 0 and increments by 1 for each constant in the const block. So in the example above, email is O, SMS is 1, and phone is 2. But remember, it's not an email, it's a sequence of numbers. Okay. Email status. So let's call this type email status iota. Like that. Okay, wait. Integer, right? Const. Wait, so the const I have email bounced iota. Wait, email bounced. Of type email status. That's 4. Email invalid. So let's do that. Invalid. No need for this. Is that good? Email valid. Delivered. Liver. Oh my god. Email opened. Opened. 0, 1, 2, 3. It's weird. Look, what would I use this for? What would be easier? Couldn't I just say 0, 1, 2, 3? I don't know. It's really weird. Go Proverbs. Don't communicate by sharing memory. Share by communicating. Share memory by communicating. Concurrency is not parallelism. Channels orchestrate, mutex serialize. The bigger the interface, the weaker the abstraction. Make the 0 value useful. Interface says nothing. Go FMT style is no one's favorite, yet Go FMT is everyone's favorite. A little copying is better than a little dependency. Oh, wow. Syscalls always be guarded with build tags. Cgo will always guarded with build tags. Cgo is not Go. With unsafe packages, there are no guarantees. Clear is better than clever. Reflection is never clear. Errors or values, don't check errors, handle them gracefully. Design the architecture and name the components, document the details. Documentation is for users, don't panic. Gopher Fest.
There we go. And, okay. The technical content stops now. Yeah, this is a very different talk. I think it's time to start philosophizing a little bit. How many of you have played the game of Go? Oh, good, lots. All right. So,
Wow, interesting. Clear is better than clever. Copying a little code is better for the users of your code. Errors or values. And we're done. Sick. Awesome. Well, I clearly, obviously, I won't be able to reflect my thing because I don't have access. But what is next for me? I don't know. I think this was learn HTTP clients with Go. Build a Pokédex. Build a blog aggregator. Learn HTTP servers. This sounds really fun. Well, awesome. Maybe I'll continue with another Go part, or maybe I just look up a YouTube tutorial on some web dev frameworks for Go and see if I can just figure it out. Or not even YouTube, I can just go backend frameworks docs, and just dug it out like that. Oh, this is the. Oh wait, hold on. RESTful API. RESTful API for Go engine. Ooh. This is using Gin. I don't know what's better. I have to do some research, but there's a lot that I know that people like using. But anyways, I think that's a good start, a good finish. Finish it fairly fast. But yeah, I'll see for tomorrow. Maybe I'll just do a leak code tomorrow as I think of some ideas to be able to go. But anyways, I'll catch y'all later. Peace.